Hello everyone and welcome back to another video of competitive programming. Today we'll be looking at British Informatics Olympiad question 1 taken from the 2010 paper. So let's just have a look at the question real quick. So the question basically states that an anagram number is a number which can be multiplied by at least one single digit number with other than 1 to become an anagram of itself. And from the English meaning of an anagram, it's just anything which can be rearranged to form itself again. And that's basically what the question says here. Like two numbers are anagrams if they can both be formed by rearranging the same combination of digits. So for example, this number is an anagram number since if you multiply it by 6, you get this number, which is made up of the exact same digits like 1, 7, 1, 4, 2, 8, 1, 1, 1, 2, and 1, 6. And likewise, if you multiply it by 7, you also get an anagram of the original number. And these are all the digits which it can be multiplied by to form an anagram of itself. But this number is not an anagram number because if you multiply it by 2, 3, 4, 5, 6, 7, 8, 9, whatever, you won't get the same combination of digits. So, for example, like something like 11 would not be an anagram number because if you multiply it by 2, you get 22, 3, you get 33. And so on. Like no combination of digits will give you the same 1 and 1 which you originally started with. And our job is to write a program which reads a single number and determines whether it's an anagram number. And we should also output each of the digits which it can be multiplied by to form the anagram of itself. So in this case, we saw that it's 2, 4, 5, 7, 8. Because if you multiply it by 2, then you get a certain number, which is an anagram basically. But 100, if you multiply by 2, 3, 4, 5, you get like 200, 300, 400, etc. None of which have the same digits as 100. So let's just look at the code real quick. So pretty much, there we go. Here's the code. We're initially accepting an array, which is basically just an input. So, for example, if they type in 41, the array will be 4 and 1. Each of these will be integers, since, they're all numbers, right? So you have to have integers. And now we'll be creating another input, which is basically from the original one, but we'll just be making everything a string. Because the reason will become quite apparent later on, because we can't really work with integers as well as we can work with strings, right? Because even though we're dealing with integers, we need to have the string manipulation properties which a string has. And now this flag will come to the function of it later, but we're just initializing it to false for now. And now for number in range 2 to 10. So this is just iterating through each possible number which our thing can be multiplied with, like our original number can be multiplied with, okay? And it can't be multiplied with 1, as the question says, so we are iterating from 2, 3, 4, 5, 6, 7, 8, all the way to 9. Remember, because range is not inclusive on the later end, so which is why we're at 10 here. And now num equals int join r. So r is basically the string of, the list which is made up of strings of the original array input, and we're converting that to a number so we can multiply it by this number over here. Now, now num currently stores the value of the new number, and this new will be the pretty much a list version of everything which is inside the num. And the reason why we're converting it into a list of strings is so we can directly compare it with this array, which is also a list of strings. So now we're creating a deep copy of this array, of the original array. Had we not had these two lines, then what would have happened is it would have just created a shallow copy, which, if you're not familiar with those terms, then pretty much a shallow copy is when it doesn't actually create a copy. It just references it to the same memory location, which means every time you modify this copy variable, the same changes are made to the array variable, which isn't what we want, because if we change this copy, we don't want the array to get changed, because in the next iteration, the array will have a different value, which will give us like a logical error basically. So this creates a deep copy, and now we're sorting both arrays of strings. So what this does is it basically, since both copy and new are the same, they're made up of individual digits, and the best way to see if they're made up of the same digits is if we sort them, because there's only one possible unique way in which each combination of digits can be sorted, which means if they are identical, then if they are anagrams of each other basically, they'll be sorted to the exact same array. So when we sort both of them, we can then compare them in the next line. If copy equals new, then we basically print the number, and then we print a space at the end. This is just like the format which they want us to output it in. So if we go back to the question, it basically says that like if we see for the first test case, it's 2, 4, 5, 7, 8. So like we just want it to be printed in that particular way. And now let's just quickly go back to the program. So we print this, and then we set flag equal true. So flag equals true, this flag basically says that whether an anagram is possible, because if an anagram is not possible, then we have to print no, like as you can see over here, we have to print no, or we can't just print like blank or something. So then after this we iterate through all possible numbers, and we would have printed all the numbers which are anagrams. And if the flag is set to false, i.e. we haven't found an anagram successfully, we just print no, and then we exit. So if we run this for the sample test case, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe, we basically get the correct output, 2, 4, 5, 7, 8. And now if we type it on like 12 or something, for example, we get no. This makes sense, right? Because 12, if you multiply by 2, like you get 24, 36, 48, etc., none of which can be rearranged for this. And now if we just test it on some of their larger sample inputs, we get 2, 3, 4, 5, 6, which aligns, and we test it on the final one, we get 7, which also aligns. So that's basically the working code for the 2017 question 1. And yeah, so I hope you took something away from this. This question was not easy if you are like new to programming, so hopefully you learned something, and I hope to see you in another competitive programming video. Thanks, bye.